The basic form of an exponential function is given right here. Y equals a times b to the x power. Okay? I need you to remember that. That's the basic form of an exponential function. Now, there's more not basic forms that we're going to talk about, obviously. Okay? But the very, very basic form is y equals a times b to the x power. Excuse me. A and b are constants. Okay? So we're going to look at some of these equations and their tables and their ratios and just make observations. We're not going to draw any conclusions until we have enough data. So if you see something after we do problem 1, shh. Okay? So, look at this first problem. It gives you this. Y equals 3 times 2 to the x power. Let me zoom in a little bit so we can see it a little bit better. Y equals 3 times 2 to the x power. Because I already told you that y equals a times b to the x power is the basic form, can you tell me what a and b are? A is 3 and b is 2. That's pretty clear, right? Okay? So, in your calculator, please enter y equals y equals 3 times 2 to the x power. Enter that into your calculator. In the graph, yes. In the graph. Once you enter it into the graph, hit Control T to look at the table. You see the table?
Yep.
Okay, somebody tell me what 0 is.
12.
I'm sorry, 0? 3. And then 1, somebody else?
6.
2?
12.
24? 48. Okay. Any questions so far? Have we done anything hard so far? No, all we did is punch stuff in and look at our calculator, right? Okay. Now let's talk about the ratio between two terms. The ratio, if we're talking about ratio, we're talking about a division problem, right? A fraction. So we want to say 6 divided by 3. 2. What is 12 divided by 6? 2. What is 24 divided by 12?
2.
Okay. What is 48 divided by 24? 2. Okay. Again, we're not making any conclusions yet. We're not drawing any conclusions. We're just observing right now. Is that fair? Okay. Look at problem number 2. What is A on problem number 2? 2. And what is B on problem number 2? 3. And how do you know that? A times B to the x power, right? Okay. So, plug this into your calculator and let's look at the table. Now, are these hard problems? Could we actually figure out this table with our own brains? For those of you who remember to bring your brains today, right, we could probably do it. But it's a little bit faster looking at the calculator, so we're taking advantage of that speed today. Okay? Somebody who hasn't spoken yet, please tell me what the table reads.
2, 6, 18, 54.
I was right.
162.
Awesome. So let's figure out the common ratio. 6 divided by 2. 18 divided by 6. 54 divided by 18. 162 divided by 54. Did you literally do 162 divided by 54? Okay. You're just trusting that it's true? Okay. Hopefully you're trusting in the right place. What about 3? 3 is a trick. I'll tell you this part. One of you is correct. A is either 0 or 1.
So I'm going to go with 0.
We're looking at 1. 1.
If it's 0, it'd be 0.
What would be 0?
Everything.
Because what am I doing with A and B? I'm multiplying them together, right? So what would A have to be in this problem? 1. So what's B?
6.
How do you know that A is not 6?
Because it's 5 to the
Because
x.
6 to the power of x.
So it's the base?
Yes.
So like the base, which starts with the letter B, would be the B value. Okay. So let's fill in the table.
Okay, do we just do 6 and we do the
6 to the x power.
just do the arrow and then x?
You sure can.
Because I keep getting weird things for the table.
Weird?
Yes. Really weird.
I mean, I see you guys every day and I think of weird, but what do you think of weird?
Okay, so it says it keeps saying that 0 is 1. No. Okay. Oh. I was doing it wrong.
Okay. So does anybody have the right answers for the table?
1, 6, 36, 216, and 1, 2, 9, 6.
Like that?
Yeah, 12, 9.
Okay. So what is 6 divided by 1? What is 36 divided by 6?
6.
What is 216 divided by 36?
6.
And what is 1296 divided by 216? Probably 6. Would someone please make sure that it is? Thank you. You're so impatient with me. Sure. I promise I have a method to my madness. It is 6. Okay. Look at number 4. Somebody who hasn't talked yet. What is A and what is B? 8 and 0.5. Okay. Somebody else who hasn't spoken yet. Can you please tell me what the table is?
Chris.
8, 4, 2, 1, and 0.5, right? Okay, so what's 4 divided by 8? That's your first reaction? 1/2 would be your first reaction, isn't it? 1/2. What's 2 divided by 4? 1/2. What's 1 divided by 2? 1/2. What's 0.5 divided by 1? That's your first reaction? 0.5? Again, I promise I have a method to my madness, so just think about this. Don't tell me what you think I want to hear. Tell me what you think. There's a difference sometimes. Everybody okay so far? Okay, look at number 5, please. What about A in number 5? 100. And what about B? 0.5. Put it in your calculator to get the table. Okay. What is 50 divided by 100? 1/2. What is 25 divided by 50? What is 12.5 divided by 25? 0.5. What is 6.25 divided by 12.5? 0.5. It would be if you put it in the calculator, because that's what the calculator would tell you. It wouldn't tell you 1/2. If you divided 50 by 100, the calculator would tell you 1/2. If you divided 6.25 by 12.5 in the calculator, it would tell you 0.5. Because there's already decimals in the problem here. There's not decimals in the problem here. That's fair. That's fair. Number 6. A, 200. And B, 0.8. Obviously, okay. First one's obviously 200.
Nope.
I don't think it'd be 0.5 maybe.
No, it's 200. It says 200. Yeah, because that's the starting.
It's 200. Okay, so what's 1? 160, 148, 128. Excuse me. 0.92. Thank you. Now, some of the other ones you could do in your head. Can you do all of these in your head?
No, you actually have.
Would you please? Thank you. Sure. Ugh. Gotcha. Sorry, I'm actually asking you to do some math and algebra. Ugh. Ridiculous. What's 160 divided by 200? 4 over 5. Okay. What is 128 divided by 160? 4 over 5. What is 102.4 divided by 128? It's going to be 0.8. And then the last one, 81.92 divided by 102.4. 0.8. Now, I know that at least one of you have figured out something about A because of your reaction a moment ago about how something is obviously that. Okay? Now, it's not obvious to everybody. Maybe all of you have figured it out, but let's make sure we all know. Okay? Why did you say that it was obvious?
Because on every table, the starting value has been A.
On every table, the starting value, what do you mean by the starting value?
0.
When x is 0, right? When x is 0, the y value is A?
Yeah, because anything to the power of 0 is 1.
Oh, so it would just multiply by A and you just get A, right? So when the question says, where does the A value show up in the table? What's our answer? When x equals 0. And it's for the reasons that she said, because anything to the 0 power is 1. And so when I multiply 1 times A, I'm always going to get A. Okay? So I just want you to be careful with your vocabulary, because when you say at the beginning of the table or at the start of the table, well, not all tables start at 0, do they? So we just want to be real specific in talking about the fact that it's when x equals 0 at the table, then my y value is my A. Does that make sense? Okay. What effect does B have on the table? It's the ratio. Let's talk about the ratio for a moment. I was picky here, I was picky here, and I was picky here, right? I said your first reaction. Your first reaction of 4 divided by 8 is a half. Okay, but your first reaction of 0.5 divided by 1, well, 0.5 divided by 1 is just going to be itself, which is 0.5. Okay? Are you comfortable enough with fractions that you know those are the same? Well, 1/2 and 0.5, yeah, probably. Right? What about this one, though? If you think about it, some of you have to think about it for a minute to know that 0.8 and 4/5 are the same. Right? So I just wanted you to be aware of that and understand that if you're doing the division in your calculator and you do 160 divided by 200, your calculator is going to tell you 4/5 because there's no decimals in that problem. You're entering it as a fraction. It's going to give you an answer as a fraction. But down here, there are decimals in this problem. When I enter decimals as part of the division problem, it's going to give me my answer as a decimal. I don't know if you knew that about your calculator or not, but there you go. Now you know something. Okay? Is everybody comfortable with this? Can you go the other way? Well, we'll see in a second. Let's take just a second real quick to make sure we can put this into words. And I want to add a couple things so that the second half of our lesson is a little bit simpler. Okay? For functions in the form y equals a times b to the x power, a is the blank. Starting value. Can I change one word? Actually, both words. Is that okay? But it means the same thing? It's okay. I just know where we're going. I just want to use some vocabulary that you're going to be okay with later. Is that okay? So we're going to call it the initial amount. If I say initial amount, does that imply that x equals 0? Kind of. Okay. What else is it called? What's it called on a graph? Close. It's the y-intercept, right? It's when x is 0, so it's the y-intercept. But starting value, starting amount is also a perfectly fine way to describe it. Okay? Is that fair? Okay. What about b? What is b? The ratio. I'm going to put two more things here in parentheses. Okay? What do I mean by that? As you go what direction in the table? As you go down the table, it's what you multiply by. If you're dividing, it would be up the table, right? But we're going down the table, so it's you multiply by to go down. Yep, you're fine. We're talking about the right things. I don't need to put the other one. That's fine. That works. The conversation we just had, that's okay. Any other notes you feel like we need to put there about B? How about this? It's the base. That kind of came into play on number 3, right? There wasn't an A value listed, so we had to have a conversation about it. We knew right away 6 was B because that's the base of the exponent. The conversation we had about A being 1 or 0, that was an important conversation to have, and I'm glad we had it. But we already knew which one B was, didn't we? Because it was the base of the exponent. Okay? When are the y values increasing? Which of these tables have a y value that's increasing? Say it louder. Close. When b is greater than 1. Look at the tables. This one's increasing, this one's increasing, this one's increasing. 1, 2, and 3 are all increasing, aren't they? The y values. Look at the b values. They're all greater than 1. I agree with you that they are greater than 0, but they are also greater than 1, and that's where we have to be. Okay? What about when is the table decreasing? When are the y values decreasing? Okay, so we have to be careful. It is between 0 and 1. Because see, all of these are positive values, aren't they? So 0 is less than b is less than or equal to 1. Ooh, no. Just less than. Ignore that. Act like it's a bug. Squash it. Oh no, that's too big. That's too small for a roach. I think roaches are bigger. I think I can get really big. I saw a video of a man with roaches in his mouth. It was gross. Wait, why are we talking about that? That's gross. Okay, let's look at number 7. Can you go backwards? If I give you the table, can you tell me A and B, tell me the ratio, and tell me the equation? Well, hold on. Let's start down here. Can you tell me A and or B?
B is 4.
How do you know B is 4? Because that's the ratio. Because we said 20 divided by 5 is 4. 80 divided by 20 is 4. 320 divided by 80 is 4. 1280 divided by 320 is 4. So I know that B value is 4. Where do I get my A value from? The initial amount. So in the table where x equals 0. When x is 0, y is 5, A is 5. If I know A and B, can I write the equation? What is it? Okay, can you tell there's a little baby x value right there? Okay, it's really tiny. Look at number 10. Don't shout it out. Write it down first if you think you know what it is. Anybody write down the B value? What did you calculate it to be?
I just did 200 divided by 500.
So you only did it once? You only found one ratio in the table? That's a bad idea. I know you can do it that way. It's not that hard to check them all, though, because I'm only asking you to check 4. Is that fair? Okay. So this is what I wrote down. What would I write down for my b value? You would write 0.4, and you would write 2/5. Are they the same? So one's a decimal and one's a fraction, right? So I would make sure what the directions say. Do the directions say it has to be a decimal or it has to be a fraction? Then choose which one you're more comfortable with, because you know they're equivalent to each other. Okay? That's what I heard first, so that's what I'm writing down. What's my a value here? 500, and I know that because it's the initial amounts where x equals 0. So my equation then is times 0.4 to the x, right? Now, a second ago I kind of freaked out when I accidentally put or equal to 1, right? What would happen if it was equal to 1? Always? So, look at this example. Y equals 4 times 1 to the x power. We can do this in our head. 1 to the 0 power is 1 times 4 is 4. 1 to the first power. 1 times 4. 4. 1 to the second power. This is going to be different now, right? Wait, 1 squared is still 1, right? 1 times 4, still 4. 1 to the third power, still 1 times 4 is 4. So, what if b was equal to 1? What would it look like on a graph? What kind of straight line? Give me a direction. Horizontal line, right? Doesn't matter how far left or right I go, I'm going to go up 4. That doesn't help me at all. That's not an exponential function, is it? Not really. Yes, the exponent is in the, the variable is in the exponent, but it's a horizontal line because of my base value. Okay? So, on this page, for homework tonight, you're going to do 8 and 9 and this one right here. Okay? 8 and 9 and this one right here. Look on this page. There's 2 problems on this page. There's this one at the top and there's this one at the bottom. I will do one of them. You will do the other one. Which one would you like me to do? First one? There's more words on the first one? Awesome. Great. We're in pre-AP and we're worried about words. Excellent. I do have a pretty good grasp? Okay, excellent. Now, a lot of times you guys accuse me of not picking very good word problems. You're like, seriously, Miss Kingston, when are we ever going to be drilling holes through the mountain? When are we ever going to be cooking with Chef Carl or whatever that guy's name was? Right? Chef Charlotte, you remember that problem? Okay. Guys, I find word problems when I can, and I try to make them as realistic as possible, because some people are going to be chefs, right? Some people are going to drill holes through mountains. Maybe not you. But before any of that can happen, how many of you are going to have to take out a college loan? Hopefully not a lot of you, but maybe some of you, okay? I'm thinking probably more than most, more than not, actually, would have to take out a college loan. So let's talk about it for a second. To help with the cost of tuition, room, and board, you take out a loan of $20,000 for college. And if that's all you have to take out for college, consider yourself blessed. Okay? Anyways, you do not have to make any payments on the loan until you leave school. That's real. That's not just made up for this problem. When you take out college loans, you take them out and you don't have to start paying them back until you leave college. So if you graduate or if you don't finish, then you have to start paying them. Does that make sense? Okay. However, the loan amount accumulates interest. So even though you're not having to pay them back, it's still earning interest. It's accumulating interest at a rate of 12% annually. To determine how much you will owe after X years of school, complete the table and the graph. Round the answer to the nearest whole dollar. So here's a nice, really pretty table and a pretty graph, but can we do either one of those without an equation? So can we figure out the equation first?
So 20,000.
Okay, what do you think 20,000 is? Oh, because we called it the initial amount, and when we get to the word problems, now that makes sense, right? So 20,000. Okay, so first of all, good job converting it to a decimal. People still forget that, even though we're in Algebra 2. Okay, so good job for that. But here's where we have to have a conversation. Because if I multiply something by 0.12, is that going to increase the amount or decrease the amount? By a lot, right?
So 1.
We have to start with 1. We have to start with 1 because it's accumulating interest. It's earning interest. It's growing in value. This number has to be 1.12. What if something was decreasing in value? What number would go right there? 0.88. Where did the 0.88 come from? You subtract 12% from 1, right? From 100%, it's 12% less. It's decreasing in amount by 12%, or it's increasing amount by 12%. So I have to start with the 100% that its value right now and add 12% to that. Does that make sense where that number comes from? To everyone? Tell me now, because I don't want to have to explain it 84 more times. We're good? Okay. So just to make sure, this is 1.12 because I have to start with the 20,000 I originally started with, and I'm increasing in value by 12%. So I add that to a 1, like a 100% that I started with, and increasing from there. If, for a chance, like maybe another problem that you might have to do, that it's decreasing in value, or it loses value, you would have to subtract. Just by happen chance. Happen chance, that's not a word. Happenstance, thank you. Okay? And then, of course, I have it to the x power because that's what my pattern is, right? A times b to the x power. Now that I have an equation, can we fill out the table in the graph? Yeah? Okay, tell me what the table is. 22,400. 25,088. Okay, so 28,000 what? Yes, correct. 099. Okay, thank you. And why did you do that again? Round to the whole dollar. Excellent. Okay, keep going. 470. Sorry about that. 7 I messed up. 247. Hopefully you can find a way better interest rate than 12%. Please don't borrow college money at 12% interest. Please. Okay? Okay, so let's graph it. 20,000. 1 is 22,000. So if I'm counting by, how am I counting by? 5,000? Because 20,000 and then that would be 25,000 and then 30,000, right? So 22,000 would be here-ish. And then 25,000, so just over that. 3 would be 28,000, so almost to there. 31,000 would be just over that, maybe like right there ish. Guys, how careful am I being here? Not very, right? It's just a really small picture of it, and I can't get exactly onto $31,470. So I'm just trying to get close. 5 is 35,000, a little over 35, so up there maybe. And then 39,000 is almost to 40,000. Now that looks pretty linear, doesn't it? Now if I put a line on it, it's not. Right? here and here. I would cover up the whole thing to connect those two dots. But remember, this is a very small picture of it. If we went to 10 and 50 and stuff, you would see the exponential function. You would see the curve. Okay? Suppose after graduating college you enter law school. How much would be owed after 8 years? $49,519. And how did you do that? Oh, okay. So you have the table already there, so you just went down to 8 on the table. How else could you do it? Couldn't you just put an 8 in the equation right there? Okay, what about 12? You go to medical school, so you're waiting now 12 years to start paying it back. $77,920. Okay, that's a lot of money, isn't it? So you see why doctors sometimes charge the amounts they do, because they need to pay back their medical loans. Okay, so what's the domain and range of this problem situation? It's not talking about the domain of this equation, because we already know the domain of this equation is all real numbers. It wants to know specifically the problem situation. What's the x value represent in this problem?
It's the
Years in school, right? It's the years in school. Can you have negative years in school? So then what's my domain? X is greater than 0? Can it be equal to 0? Yes, you can have 0 years in school. What would it look like in interval notation?
bracket 0 to infinity.
Excellent. What's my range for this problem situation? What about it would start at 20,000 and just go up, right? Now, realistically, what's going to happen? Let's talk about the doctor in medical school. What's going to happen after 12 years? It's going to start decreasing, right? Because he's going to start paying it, so it's going to start going less and less. But we don't know. We don't know how long it's going to stay in school. Somebody last period said they're going to stay in school for the rest of their life then, so they don't have to start paying the loans back.
That would be great.
That would be weird. Yeah.
Where's
What about interval notation?
bracket 20,000, comma infinity parentheses?
Now that's not really realistic, because it's not just going to always keep getting bigger. Will it even get less than 20,000 in that situation? Yeah, so it would get all the way to 0, right? But we don't know how long that person's staying in school, so we don't know what it's going to get up to. So we can't really say like a upper bound, a higher bound. Okay, so you're doing this bottom one then, right? You're doing the bottom one, and you're doing 8 and 9, and then this one on the side. Got it? Do you have any questions about any of this? Somebody asked me a question that they don't understand or think somebody else might not understand about exponential functions, what we talked about today. Anything about this stuff? All pretty straightforward? Everybody's feeling comfortable with this? Okay.